Global Navigation Satellite System is also called GNSS, used for position navigation and time synchronization on a global basis. By using a navigation satellite to transmit signals to the object, the distance between the object and the satellite can be calculated with the transmission speed and the transmission time. When 4 or more satellites transmit signals to one object at the same time, the distances between the object and satellites can be calculated. The position of the object is given by the intersection point of the circles by drawing with the satellites as the centers and the distances as the radiuses. GNSS provides many advantages, such as a short observation time, 3-dimensional coordinates, easy and round-the-clock operation, and more. China's Beidou, America's GPS, Russia's GLONASS, and the EU's Galileo are the most commonly used. However, GNSS probably suffers from positioning errors for various reasons. For example, satellite signals will be refracted when they pass through the atmosphere, and will be reflected when they encounter obstacles, which will cause errors when calculating signal transmission time, and then errors in distance calculations, resulting in positioning errors of tens or even hundreds of meters. How do we solve this problem? The answer is the differential positioning technology. This solution starts by setting a base station with a known position, then a connection through GNSS satellites to obtain a measured position of the base station. From this, the error between the known and measured positions can be calculated. Then, the base station can provide correction signals based on this error to correct other measurements. The impacts of tropospheric and ionosphere's movements on satellite positioning are basically consistent within 20 to 40 kilometers from the base station. Therefore, as long as the correction signals are sent to drones in real time, drones in this range can determine their accurate positions precise to the decimeter or even the centimeter. This is called Real-time Kinematic Technology, also called RTK technology. Traditional RTK technology requires the establishment of a base station for each use, which is requiring much time and effort. Instead, we can establish a network by evenly deploying multiple base stations over a large area. This type of network is known as the Continuously Operating Reference Stations, CORS system. With the composite correction signals sent via the network in real time, drones within the range can perform fast and precise real-time positioning. This is also called network RTK technology. However, signals need to be received all the time when using RTK. The drone may be unable to receive the signals due to the environment effects or no internet connection possible. In this case, we can measure with PPK technique, which means post-processed kinematic. Through the positioning measurement, we use software to process data collected from the drone and the base station to compute the accurate position of the drone. So this technique is not performed in real time. In order to make it easier, Network PPK Solution Service is developed in recent years, and the differential data solution can be completed by simply uploading the data collected from the aircraft. When a drone enters areas with high electromagnetic interference, such as areas around electrical substations or iron ore, its compass may get disturbed and the drone couldn't calculate the direction it is pointing, which will usually result in the drone being unstable. DJI Dual Antennas Tech could solve this issue. By having a second antenna to send and receive signals, the drone will receive 2 sets of data from each of the antennas. Using one dataset as the benchmark, it could calculate the precise locations of both antennas and accurate heading. The longer distance between 2 RTK antennas also leads to the more precise navigation of the aircraft. Above all, the development of positioning technique improves the positioning accuracy, mapping accuracy, and drone safety greatly.